All right, so what you're going to see on section 6 is you're going to see you guys solving for x. And that's the main thing with this. Now, on this first stuff today, for some of these, you're going to have where they're written in exponential form. Okay, now, the way that I do this, there's two different options for you. The first option we're going to try to look at is there a way that I can rewrite the numbers so they have the same base? If they have the same base, then you can set the exponents equal to each other and move forward. So for instance, on this particular problem, I've got 6 as the left-hand base, 36 as the right-hand base. I can't bump the number up, but I can always bring the number down. Can 36 be rewritten as 6 to the somethings? Yeah. 6 what? Squared. So this side I'm not going to adjust, but this side was really 6 squared, and then 3x minus 5. Now, for this particular part right here, this is where some of you guys were messing up on your last test. You do not add the 2 in there. What do you do to it? Distribute it or multiply it. Right. So that gets multiplied into each piece. So I got 6 to the 2x minus 6 equals 6 to the 6x minus 10. Once the bases are the same, then what you can do is you can eliminate that and get rid of it and just set the exponents equal to each other. The reason why that happens is this equal sign is all empowering, meaning that it has to be the same on both sides. When you have an equal sign in there, you are saying that that is exactly the same as this. So as far as that goes, once you have them equal like that, once you have the bases the same, then the exponents better be equal also. So then on the side over here, all I'm going to do is put 2x minus 6 equals 6x minus 10. Solve for x. How do I do that? Add 10 to both sides and subtract 2x. When I do that, negative 6 plus 10 is 4. And 6x minus 2x is 4x. Then what? And 4 divided by 4 is 1. Okay? What do you think? The first thing that you got to do, identify the bases, see if they can be rewritten as each other. If they can, then we do that. We put the bases equal, or we put the exponents equal to, and we solve for x. Honestly, that's the same format we did in the first half of the chapter when we rewrote the bases and then just wrote the exponent. It's the same exact thing as that. Are you guys comfortable with that? Now, what if you can't? What if we have 2 to the x equals 7? Can I make a 2 into a 7 or a 7 into a 2? No. So for this particular thing, your book shows one way. I like to do it the way that I always did it, so we're going to do it that way. Okay, and here's how I do this. Whenever I'm trying to get rid of it, and if I cannot make the bases the same, there's no way I can make a 2 into a 7 or 7 into a 2. So that, what we did on the last problem, is out the window. Then in order to actually get the x out of the exponent, I'm going to log both sides. So the first thing I'm going to do is I'm going to throw a log into both sides like that. Okay? Once I do that, those properties or those laws that we talked about in section 5, the exponent rule comes into play, which means this can go where? In the front. So now that's x times the log of 2 equals the log of 7. And how do you solve for x? Divide. Because in order to get rid of multiply, you divide. So you divide by the log of 2. Now here's where your calculator comes into play. On Friday, we talked about the change of base formula where we took the log of blah divided by the log of blah. It's the same thing. It's the log of 7 divided by the log of 2. Careful where you put your parentheses. Make sure you close everything out. So it should be log 7, close it, divided by log 2, close it. And I think it wants you to go with your 3 decimal places. What do you get? 2.807. And you're done. Okay. Can I rewrite this? Oop. That log shouldn't be there yet. Can I rewrite this so that the bases are the same? No. I cannot make a 5 into a 2 or vice versa. So therefore, what do I do to both sides? Log them. Once I log it, what happens? Then I can move the x in front. Why? It's one of the properties, right? So x times the log of 2 equals the log of 5. Now what? Divide by log 2. And approximately what answer comes out? Done? What do you guys think? Good.
Tomorrow's already Wednesday. I know. Yeah.
Okay.
What is?
Breakfast was canceled yesterday.
Why?
Because we haven't had a day out in that one. Like we've had breakfasts on Sunday and everything.
All right. On this particular type, is the exponent all by itself? No. Now remember, when you're solving equations, you're also undoing the order of operations. That's the main thing. So the first thing that should move is there any adding or subtracting in this problem? How do I move it? Add 7. If I add 7, what's 13 plus 7? Now, is there any multiplying or dividing in this problem? Divide everything by 4. So I have e to the negative 0.3. Oops. X equals 5. Now, can I make e a 5 or 5 an e? No. So, how do I get rid of e? ln. Good. I ln both sides. ln, remember, stood for the natural log. So technically, I'm still logging both sides. I'm just more specific with this one. I'm natural logging it. So I'm ln'ing both sides. What do I get on the left? Negative 0.3x, right? Because that e and the ln cancel out. And what's the other side? ln of 5. Now how do I solve for x? I divide by negative 0.3 because I'm solving for x. And then when I type that in, you'd hit the ln button and it should pop up with a parenthesis. Then you type a 5 and then you close it, then divide it by a negative 0.3. And what number spits out? Negative 5 point what? What do you think? Are you guys comfortable with that?
Yep.
Okay. That's about as hard as they get. Now, the only other thing that I want to make sure you guys are aware of is this. Okay, this formula,
Is that an R?
it is an R. Yeah.
Are both of them an R?
Yes. One's a capital R, one's a lowercase r. Okay. On the TR, they're both uppercase. On the RT, that's a lowercase.
Yeah.
Okay. Now, this formula is actually used for a lot of different things. One of the things that it is used for, it is used in cooking. Okay. Have you ever read a package like for a frozen pizza and it says cook for 8 to 12 minutes and then let cool for 3 minutes? Right? So you don't burn the roof of your mouth. And that actually was done using a formula by Sir Isaac. This is Newton's law of cooling. So when he was making his figs, he decided that he better figure out how to make them cool properly. Right?
Yep.
Get it?
Yep.
He didn't make them. Okay. So here's another option for you though. This does not just involve cooking. And other people use the same formula. There are people that are in this community that use this when they find a dead body. Medical examiners and coroners, when they take the temperature of your liver, use this formula to figure out how long you've been dead for. So when they go to, if you ever watch those shows like NCIS or CSI, and they come up and they say that the body's been dead for 8 hours, it was because of this formula. It's not that you find it, it's
Science.
okay. So anyway, here's what they all mean. TO stands for the initial temperature. So for example, if it is a body that we're talking about, what's the initial temperature? 98.6. If they're talking about like a pizza or a pie or anything like that, they'll give you what the initial temperature was. Okay? Engines also, cooling wise. Okay, Bryce, I know you're in automotive. Is it important to let the engine cool if, let's say, you're working with changing the antifreeze? Yeah. Yeah, it's very hot. And what could happen potentially if you accidentally open the cap if it's still too hot?
Yeah, the system's so pressurized it'll blow antifreeze everywhere.
And burn you. Very good. Another thing that you could also do because of temperature wise is you could figure out whether or not a cylinder is actually performing right. If it's not performing right, it's not heating up. Okay? So, that's what the TO stands for. T is the temperature. That's how much it is now. That lowercase t is the time it takes. TR is the surrounding temperature. So for example, looking at some of the TV shows that we have, CSI is based in Vegas. Is Vegas's temperature a little bit different than ours? Yes. When I was there last summer in July, I think it topped out about 118 was one of the days. Okay? So it's pretty warm there. A body's not going to cool as fast in the desert than it is in North Dakota. Okay? And R is the rate. That's usually as a percentage. Okay? So what they're going to do for you on the problem that's like this is that you're going to be given all the information and you're going to be asked to plug it in and see what the temperature is now. Or you may have to work backwards to figure out how long. That's what those people, like on NCIS, if you've ever watched that show, Ducky is the medical coroner. It takes, when he does the temperature probe into your liver, he's actually figuring out lowercase t, or the time. So they have to add and subtract some stuff, divide it out, just like you did in the last problem. Take the natural log of both sides, divide it, and you have your answer. Okay? So you will be given enough info, and you'll have to plug it in and see what you get. Okay?
Okay.
Are you comfortable with solving backwards?
Yep.
First types of ones that you're going to want to do, make sure the bases are, if they can equal each other, do that. It's faster. It's easier. Then, if they cannot, then you take the log of both sides and move the exponent to the front. Are you okay with this? Okay. So, on page 338, I already forgot what it was. Five to 19 odd.